Hello, how are you friends? I am Ganesh Misal and today in this video I am teaching to you a new chapter of class 12 chemistry part first crystalline solids and amorphous solids. Please like this video and subscribe my channel and comment, share, and for my new video updates click on the bell icon. So let's start our video. In this video we will see the difference between crystalline solids and amorphous solids. For this, first of all, we draw two figures, crystalline solids and amorphous solids. First of all, we draw crystalline solid figure of crystalline solids like this. In crystalline solids, there is orderly, regular, long-range arrangement of constituent particles. Means in this crystalline solids, there is orderly, regular arrangement of constituent particles like this. Orderly, regular arrangement. Orderly, regular arrangement. Like this. There is orderly, regular and periodically repeating pattern is observed. Regular and periodically repeating pattern is observed. Orderly, regular arrangement like this. Means there is orderly, regular arrangement of constituent particles and regular and periodically repeating pattern is observed, and these crystalline solids have a definite characteristic shape. Why definite characteristic shape? Because these crystalline solids having orderly, regular arrangement, and this arrangement of crystalline particles is long range rearrangement. In contrast, in amorphous solids, we draw the figure of amorphous solids. These solids have irregular shape. We draw one figure. These solids have irregular shape. And there is a regular arrangement, but this arrangement is short range. Regular arrangement, like one particle here, one particle here, one particle here. Regular but short range arrangement. One particle here, one particle here, one particle here. In this way. Means there is regular but short range arrangement of constituent particles. Means this arrangement is called random arrangement, randomly arrangement. And in this amorphous solids, regular and periodically repeating pattern is not observed. Means periodically repeating pattern is not observed, and that's why this, due to this irregular arrangement, random arrangement of constituent particles, these solids have irregular shape. These solids have irregular shape, and these amorphous solids are not homogeneous. Not homogeneous means due to this random arrangement of constituent particles, these amorphous solids are non-homogeneous. In contrast, in crystalline solids have regular arrangement of constituent particles, and these crystalline solids are homogeneous solids because these crystalline solids have as regular and periodically repeating pattern observed, and that's why these solids are homogeneous solids. Other difference is crystalline solids are true solids. Because why crystalline solids are true solids? Because these solids shows all the properties of solids. Crystalline solids shows all the properties of solids. That's why crystalline solids are true solids. But but amorphous solids, amorphous solids are not true solids. These solids are called pseudo solids because these solids does not shows all the properties of solids. That's why these solids are called pseudo solids, or other name of amorphous solid is supercooled liquids because they shows some properties of liquids. That's why they are called supercooled liquids because they made by supercooling the liquids. Then other difference is for crystalline solids is crystalline solids, this figure, crystalline solids, pure crystalline solids exhibit sharp melting points, means they melt completely at one constant temperature, means they exhibit sharp melting points, means they exhibit a fixed melting point. But amorphous solids does not exhibit definite and sharp melting point, and they melt over a range of temperature. How these crystalline solids exhibit sharp melting points, fixed melting point. For example, one crystalline solid A, and this solid shows a fixed melting point, for example 56 degree Celsius, means one crystalline solid, this solid shows 56 degree melting point. Then this substance does not change its melting point temperature 56 degrees Celsius. In the contrast, the amorphous solids melt over a range of temperature. For example, one amorphous solid, it's melt over 60 degree to 75 degree in this range of temperature, means they have does not a fixed melting points. Amorphous solids does not have fixed melting point, they melt over a range of temperature. Then another difference of crystalline solids is they show phenomenon of anisotropy, means they are anisotropic. Crystalline solids are anisotropic, means we draw a figure of crystalline solids, this type of crystalline solids, and we see the concept of anisotropy. Then anisotropy means crystalline solids shows anisotropy means the physical property like refractive index, dielectric constant, or electrical conductance. These properties changes with direction. When we change the direction of the physical property, then change the physical property. For example, we measure the physical property like electrical conductance in this direction. Then there is one type of value of electrical conductance in this direction. when we measure the electrical conductance property in this direction, then there is the value of electrical conductance change in this direction. Also, when we measure the electrical conductance property in this direction, then in the direction also change the electrical conductance, value of electrical conductance. Means anisotropy means when we measure the physical properties like electrical conductance, dielectric constant, then this the value of physical property changes with direction is called anisotropy. Means crystalline solid shows anisotropy. In contrast, amorphous solids shows phenomenon of isotropy. Means like we consider these amorphous solids and there is random arrangement of particles. When we measure the electrical conductance property in this direction, then in the direction there is one type of value of electrical conductance, and when we measure this property in this direction, electrical conductance, means it we obtain the same value of electrical conductance property, and when we measure the value is in this direction, then we obtain a same value of electrical conductance property. Means and as isotropy means the when we measure the properties, the physical properties like electrical conductance does not change with change of directions. Means the physical properties like electrical conductance does not change with direction. When we measure the electrical conductance property in this direction, then we obtain the same value. When we measure the electrical conductance property in this direction, then we also obtain the same value. When we measure electrical conductance property in the direction, then we obtain the same value of electrical conductance. Means the physical property does not change with change of direction in amorphous solids. That's why amorphous solid shows the phenomenon of isotropy. Then another difference is heat of fusion. Crystalline solids, in crystalline solids, heat of fusion is definite. First of all, we know the concept of heat of fusion. Heat of fusion is defined as the amount of heat required to convert solid into liquid. Means heat of fusion means the amount of heat is required to convert the solid into liquid. This is called heat of fusion, and this heat of fusion is definite for crystalline solids, and heat of fusion is not definite for amorphous solids, because in amorphous solid there is random arrangement, there is not regular arrangement of crystal particles, and in crystalline solids there is regular and uniform and regular and periodically repeating arrangement of crystal particles, because this heat of fusion for crystalline solid is definite. Then we see the examples of crystalline solids. For example, diamond and table salt, these are the examples of crystalline solids. And for amorphous solids, glass, plastic, and rubber, these examples for amorphous solids. These examples for amorphous solids. Then we see another difference for the crystalline solids. The crystalline solids have edges. Crystalline solids have edges. We see the how these crystalline solids having edges. We take the example of crystalline solids. Crystalline solids have a definite shape because regular arrangement of constituent particles. They have edges because when we break the crystalline solid in this direction, then we obtain this type of edge. And they have edges. And in contrast, in amorphous solids, they does not have edges. Another difference is crystalline solids form a three-dimensional lattice structure. And in amorphous solids they does not have three-dimensional lattice structure. In crystalline solids there is, for example, these particles, crystalline solids, these particles, in the spaces between the atoms are very less. In the spaces between these two atoms are very less due to the high intermolecular forces. In this the intermolecular forces between the atoms are high. That's why. And in contrast, in amorphous solids there is the space between the atoms is very large due to low intermolecular forces. Then we take another difference. For example, this is crystalline solid, and this type of the particles, we take this type of particles, and then when we break the crystalline solid along a particular point, from this particular point and from this particular direction, then these crystalline solids break into even pieces with regular edges. For example, from this direction and this point we break the crystalline solid. Then we take this type of the part of, then we get this type of part, this type of the parts. Then we get this type of the part, and the edges of this breaked parts are regular edges. How edges? These edges are regular edges, does not irregular edges. These edges. In contrast, when we break the amorphous solids, for example, we break the amorphous solids from this direction, we break amorphous solids from this direction, then we get the then we get then we get uneven pieces with irregular edges. We get uneven pieces means these pieces are not the same. Uneven pieces. Uneven pieces. Then we get uneven pieces and with irregular edges. These edges are does not regular. This means that means these edges are not regular. These edges are irregular. In this way, today in this video we see the difference between amorphous solids and crystalline solids. In another video we will see the another point. Thank you friends.